Tēnā koe. Kia koutou I haere mai ana ki tēnei hui. Nau mai, haere mai, whakatau mai rā. Ko Rachel toku ingoa, ko Haarlemmermeer te awa, ko Air New Zealand te waka, ko Ngāti Tāti taku iwi, no horana ahau. He mata whakawhāna ki Pākihi au, ki te herenga waka, ke tamaki makaurau taku tāri, mai te iho ki te pai o te tātou hui. Tēnā tātou katoa. Good evening, everybody, and welcome. Delighted to have you all here. It's been great seeing familiar faces, some long-lost friends, and some new faces too. So it's great, and we're really appreciative of you taking your time out of your busy schedules to be here with us this evening. It's certainly proving to be a very popular topic. So we're very grateful for Ilan Noy for making the trip all the way from Wellington to be with us here in Auckland this evening. My name is Rachel Manirakiza. I'm the Senior Business Development Manager here at the Auckland premises for Victoria University. I form part of the Future Students team for Te Herenga Waka. So a lot of our work is with prospective students at the university, spreading the good work and telling the Aucklanders all to move down to Wellington. Mostly what we do. Helen Doherty you would have met as you came in this evening as well. She is our Senior Engagement and Alumni Advisor, and she has been largely responsible for organising this event for us. So we'll thank her appropriately when she comes into the room a little bit later on. Now, just to let you know that we are recording the session this evening. The camera is behind you, so you don't need to worry about putting your best selfie face on. Ilan will be at the front here being recorded. If anybody says anything untoward, which is probably most likely to be me, we'll just edit that bit out, so don't worry. So that we can share this recording, because we've had a number of people who would have liked to have been here this evening but can't make it, so we'd like to share the recording of the presentation with them this evening. Tonight is all about connecting with you as alumni. I've already heard some great stories that I've never heard before. Thank you, Sue. Well done. But it's also about sharing some of the research and the work that's been happening at Victoria University Wellington. And we are really pleased that Professor Ilan Noy has joined us this evening from Wellington to share some of the work that he's currently doing. Ilan is a professor in economics and holds the chair in the economics of disasters and climate change. He and his team are based within the Wellington School of Business and Government and based at our Pipitea campus. Ilan and his research group study disasters, including earthquakes, epidemics, droughts, cyclones, and I imagine you've been pretty busy lately. As we see these events becoming more intense, their economic impacts become more severe and more damaging as well. And I do just want to take a moment to acknowledge that some of us in the room have been impacted by some of the recent floods here in Auckland. You can talk and have your personal stories about the cost of climate change. I know that can be a very stressful thing, so kia kaha, our thoughts are with you. Tonight, Ilan will discuss the cost of climate change, how greenhouse gas emissions impact on those costs, and what this might mean for insurance in the future. Thank you, Ilan, for being with us tonight and giving us a little insight into the very important and very relevant work that you and your team are doing. Thank you very much.
תודה כתוב, ברוכים הבאים ושלום. Yes, so the talk today is about climate change, and specifically,
is it on?
This works. Work. When we think of the cost of climate change, we frequently talk about two things. We talk about the sea level rise, and we talk about the increase in the average temperature. And a lot of the media discussions, for example, about climate change is whether our world is heating by 1.5 degrees, or 2 degrees, or 2.5 degrees, or maybe even we'll end up with a world of 3 or 4 degrees, and hopefully not. I think that to some extent that discussion is a problem, because what we're doing is we're trying to look for the impact of climate change where it's easiest to visualize, maybe. It's really easy to visualize, Manhattan underwater. But the real cost of climate change is somewhere else, right? So what we're doing is a lot of times we're looking for the keys under the streetlight rather than where they truly are. And the cost of climate change is in the extreme weather events. That's what I'm going to try and argue today. And when I'm talking about extreme weather events, I'm talking about droughts, I'm talking about floods, I'm talking about storms, heat waves, and all of these sort of extreme weather phenomena. Okay, that's where the real cost of climate change is experienced, is already being experienced by us. And what I want to do today is a little bit try to quantify a little bit how much that is. Okay, and maybe give a few more insights about what we can say about that cost of climate change, that cost of extreme weather events. Okay, now we know, and forgive me, this is the only sort of technical graph I'm going to do here. We know that if we look at precipitation, if we look at moisture coming from the sky, climate change is shifting the distribution of the amount of rain that's coming from the sky. So if before climate change, so let's imagine a world 100 years ago without so much greenhouse gases in the atmosphere, that's the amount of precipitation that we had. I'm sorry here, I'm colorblind and I'm not sure which colors these lines are.
Intensity is blue.
Blue.
Oh, you mean that the bottom line is red?
Yes.
Yeah, it's red.
Red and
Orange.
So orange, red was the color before this screen, the same colors.
Yes.
So the red is where precipitation was before climate change. And what climate change is doing already, it's shifting the curve to the right, meaning we have more rain. Why do we have more rain? This is sort of primary school science. The ocean is warmer, and because of that there is more evaporation, and because of that there is more moisture in the air and more falls on land. Right? So the science here is not groundbreaking in any way. Okay? But that curve is shifting to the right. Okay? So if we think, let's hypothetically say extratropical cyclone Gabrielle was somewhere here. On that point there, it's on the orange line because we are now in a world in which greenhouse gas, there are plenty of greenhouse gases in the atmosphere. So there is now 420 parts per million for carbon dioxide in the atmosphere. And before we have put all that carbon dioxide in the atmosphere, we had maybe the average was maybe 280. Right? So there's the climate is different today because of climate change. So we are on that orange line. Now the question we can ask then, when tropical cyclone Gabrielle, if you compare that vertical shift in the curve, right? That basically that distance is by how much was extratropical cyclone Gabrielle became more likely because of climate change. So that's one way to think about it. Okay, so we had experienced this. The storm, or the floods in Auckland, it's the same argument, that event became more likely because of climate change. Okay? So if before the event, before climate change, this was maybe a 1 in, 200-year event, now it's a 1 in 100 year because of climate change. It's becoming more frequent. Okay? Similarly, you can think of the horizontal shift in this curve. The curve shifted. It doesn't matter if you can call it the horizontal shift or you can call it a vertical shift, right? The horizontal part is by how much ex-tropical cyclone Gabrielle became more intense. So that's a different way to think about it, right? The storm became more intense, it dropped more rain because of climate change. So either it became more frequent, that's the vertical shift, or either it became more intense because of climate change. It's basically two sides of the same coin. Right? Both of these just denote that the curve is shifted to the right. Okay? Now what I want to do is show you a few papers or a few research projects that I've been involved in which we've used that concept, either the vertical shift or the horizontal shift, to say something about the role of climate change in extreme weather events. And specifically, because I'm an economist, I'm not a climate scientist, specifically in the economic cost of those events. Okay? So I'm going to start with a paper that we did with a bunch of people. I'm not going to read you all the names, you can see them there. And we looked at the costs of the climate change attributed costs of extreme weather events in Aotearoa, New Zealand, in terms of floods and droughts. Okay. So look at the floods. These are all the floods from all the big floods between the year 2007 and 2017. Why did we end in 2017? Well, we put together that project. We started that project in 2018. So, so the data that we had, or actually 2019, so the data we had was up to 2017. Okay? So these are all the big floods, and the cost is only the insured cost for each one of those floods. Right? So how much insurance companies paid for those floods? Okay? Why am I looking only at the insured losses, only at the insured damages? How much insurance paid? Because that's the only number I know. Why? Because we don't know how much these floods cost. We only know how much insurance companies pay. Okay? That's sort of a bit of a sad fact here, is that we have actually no idea how much these events cost. Right? For example, the Auckland floods or the ex-tropical cyclone Gabrielle floods, we will never know. If current data collection practices continue, we will never know how much they cost us. Okay? Because nobody is collecting that data. So what we have from the insurance companies, actually from the Insurance Council, which is sort of the lobbying group for the insurance companies, they collect the data on how much their members, their insurance companies, pay for each one of those floods. And you can see the list there. The most costliest event in this list is the 2017 flood in the North Island. Now what do? We look at what we call the fraction of attributable risk to climate change. So the fraction of that event that is attributable to climate change. How do we do that? Well, I don't do that because I'm not a climate scientist. My colleagues, so all this list of people there are climate scientists. They run their climate models with 420 parts per million of carbon dioxide in the atmosphere, and run the same model with 280 parts per million of carbon dioxide in the atmosphere. So run the climate models with climate change and without climate change. And then they look at the difference. Okay? And their conclusion is for each one of those, actually there was a different conclusion, for each one of those floods, a different fraction of that flood is because of climate change. Why is it different for each flood? Because the meteorological characteristics of that flood were different. Different season, different location, different, atmospheric rivers were flowing, all of that stuff. I don't know, I get it.
Different rain.
Okay. So, and then what we basically do is we just multiply the one by the other. And then we can say, out of, for example, that most costliest event in the North Island in 2017, 35% was because of climate change. That meant that $32 million is because of climate change. So we anyway would have had a flood, But that flood would have been significantly less costly if we didn't have so much carbon dioxide and other greenhouse gases. Okay, so you can understand the logic here. And when we sort of total that up, we get that over that 10 years, from 2007 to 2017, $140 million of flood costs, of only the insured flood costs, were because of climate change. Okay? So total cost, how much I don't know, was because of climate change. So, for example, just to give you maybe sort of a ballpark figure, the Treasury produced some preliminary estimates for the floods in February, sort of January, February. So the combined events in Auckland and Gabrielle a few days ago, and they said about half of this is infrastructure, half of the damages are infrastructure, a quarter is residential damage, and a quarter is commercial damage. Okay, the infrastructure is not insured at all. Or almost not at all. The commercial is maybe insured half or maybe a bit more, and residential is mostly insured. Okay? So roughly, the overall cost, at least in this, according to this Treasury estimate, is about at least 3 or 4 times as much as the insured costs. Okay? So sort of just as a guess, and this is a guess, multiply this by 3 or 4 to get overall damages from these floods. Can we kill this microphone? Because then whenever I come here, it's okay. There's only one problem with this. And this is if we look at the same data we used. So this is data from the Insurance Council. Okay. For every year, how much are we paying for extreme weather events? How much the insurance companies, not we, the insurance companies are paying in insured damages from extreme weather events in New Zealand, right? You can see the data and the data here, and unfortunately, the data we used is this circle here. So the last few years were much worse than before, right? And we just used the data from just before, sort of all turned to last year. Okay. So if I've done the same analysis today, the numbers would have been much, much higher. Okay. Let me just point out that this is taken from a recent report by the Treasury on the cost of climate change. This graph, right? So they have, for some whatever reason, they published this in 2 weeks ago, but they don't have 2022. The figure for 2022 is a little bit higher than 2021, so it's just over 350, okay? And the figure for 2023, well, we don't know, we're only, 4 months into it, but it's already at least 3 times as much as 2022, okay? It's already at least $1 billion. Okay, so it's much, much, and sort of take the ceiling and go a bit higher and hopefully, we won't get to the, 4th row here. We won't get to the 6th row this year in terms of the cost. So my point is that $140 million that I've shown you is a vast underestimate, both because it doesn't contain uninsured damages, and because we somehow blacked out and we picked all the small years or the years in which the costs were not very, very high. This is unfortunate because, for example, in this report, Treasury is citing that $140 million figure in quite a few places there. So I think it's an underestimate. Okay, that's one way to think about it. And in principle, we could do the same thing for think of the event that we just experienced, that you experienced here in Auckland and people experienced in Tairāwhiti and in Hawke's Bay and so forth. We could calculate how much the share of that event is because of climate change. Right? I don't exactly know, but I think ballpark is maybe 20%. And then, so calculate how much are we paying because of climate change for this event. And we are paying because a lot of that is going to be borne by government and you're all obedient taxpayers. Right? So we are paying for this. Okay. Another research that we've done using the same kind of approach with different data, we looked at Hurricane Harvey, which was a hurricane that hit the United States in 2017. Okay. This was the second costliest hurricane in US history. What was unique about it is, to quote the President of the United States at the time, it was very wet. and he added from the standpoint of water.
Is that the president you're talking about?
That's the president whose name we are not going to mention. But he was right. It was very, very low. That is, and typically, actually, sort of the cyclone here. Hurricanes, which is just another name for tropical cyclone, the damage from them is from almost all the damage is from the water. From the rain, the flooding, the riverine flooding, the surface flooding, and the coastal flooding associated with the storm surge. But for some mysterious reason, we always classify them by the wind speed. So we say, this is a category 3 or a category 4 or a category 5 based on the wind speed. Well, actually, that doesn't really matter. What matters is how much rain they drop. Okay, so we have these sort of counterintuitive situations when, for example, this Hurricane Harvey was only category 3, and they can go up to category 5, but it was the second costliest event in US history after Hurricane Katrina, which inundated New Orleans back in 2005. Right. Anyway, so what was unique about Hurricane Harvey, not a very strong hurricane according to the wind speed categories, but it moved very, very slowly. Okay? And it moved over the ocean when the ocean was unusually warm. Before it hit land just next to Houston. Right? So both of these characteristics are associated with climate change. Right? Hurricanes or tropical cyclones move more slowly when the air is warmer. Of course, when they move more slowly, they drop more rain at each location. Right? And it had more moisture because the ocean was warmer, so there was more evaporation, and therefore there was more moisture or more energy. Right? So what we do is we combine this idea that this hurricane dropped more rain because of climate change. Okay? By how much? Well, the scientists have a bit of a disagreement there, but we looked at a bunch of studies and we concluded that sort of a safe, not quite consensus, but sort of a middle estimate is 38%. It doesn't really matter if it's 38 or 35 or 30 or 40, but let's go with me. That's the sort of the most authoritative research that we've seen. It's 38% of the rain was because of climate change. So if there was no climate change, that Hurricane Harvey would have just dropped less rain. By how much? By 38%. Okay? So then we can sort of with map, with hydrological, with flood mapping, with flood modeling, we can look at which properties were flooded, right? And then reduce the amount of rain by 38%, and then see which properties would have flooded. Right? Fewer properties would have been flooded with 38% less rain. It's an obvious observation, right? But the question we asked is, how many fewer properties? And by how much would they flood less? Because some properties would have flooded anyway, but would have flooded by less if there is 38% less rain. Okay? So we do that sort of flood mapping, and then we combine that with some socioeconomic data to say something about the distribution of these impacts. And what do we, and this is just an example. So again, my colorblindness sort of gets the better of me here. But this is the way that the flood was, actually. So that's a map of the flood. And that's a map of how the flood would have looked like with 38% less rain. Okay? You follow me? Okay. And what we can do, because it's much more detailed data, we can look for every single house in the city of Houston and say how much it flooded and how much it would have flooded less because if there was no climate change. Okay? The thought experiment here is a bit troubling because without climate change, the city of Houston wouldn't exist. The city of Houston is built on oil. Right? So it's a bit of a strange concept of imagining the city of Houston without climate change. Okay, but you know, that's the way it is. That's what research needs to do sometimes. Okay, so what can we conclude? And this was a bit of a surprise for us. So we reduced the rain by 38%. That meant that 50% fewer properties would have flooded. So half the properties would have not flooded if there was only 38% less rain. So you would sort of expect, okay, 38% less rain and 38% fewer properties would flood. No, actually 50% fewer properties would flood. Okay? So 50% flooded because of purely because of climate change, 50% would have flooded anyway. Okay? Now, when you look at the damages, it's even more extreme, right? So almost 60% of the damages because of climate change. Okay? So you reduce the rain by 38%, you reduce the amount of properties that would flood by 50%, and you reduce the amount of damages by 60%. Okay? So that's quite a striking, I think, piece of information. So just by making the event somewhat stronger, we're increasing the damages by much more. Okay? So that's one thing we can say about this. Now this is true in the context of Hurricane Harvey in Houston. I don't know if that is true in the context of Auckland and the floods in New Jersey. But possibly it is. The other thing we can do is we can sort of look at more sort of socioeconomic characteristics of that flood, and what we find is, to our surprise again, that's sometimes nice about research, you find things you didn't know. Hispanics were more exposed to this climate change-induced flood. Right? So you can sort of divide the whole population of Houston into 6 groups, right? One is those living in properties that were not flooded at all. Okay. C is groups that flooded but would have anyway flooded even if we removed 38% of the rain. And B, properties that flooded, but if we remove 38% of the flood, they wouldn't flood. Okay? And then we can also divide them between those that were insured and those that were uninsured. Okay? Fortunately for us, that distinction is less relevant here because most people are insured. Not everyone, but by far a bigger share of the population is insured for floods. Okay? We don't exactly know how, but past events suggest that more than 90% of houses are insured for floods.
If your house has a mortgage, the mortgagor will ensure that it will insist you have an insurance policy.
Yeah, that's true in the US, by the way, as well. But, so sort of, yes, so when you issue a mortgage, when you go to get a mortgage from a bank here, they will insist you buy insurance. They don't monitor that you continue buying insurance afterwards. Right? So it's only at the time of issuance of the mortgage that they check. Now, in principle, you're still obligated to maintain insurance. So if the bank retroactively finds out, wait a minute, you didn't have insurance, they can, that's what they call a technical default. You've defaulted on your mortgage. right? But in practice, they don't monitor this. They don't monitor it here, and they don't monitor it in the US as well.
Can I just ask, this is residential properties only?
Yes. Yeah. We don't have information about commercial properties. Not there, and actually not here as well. So it's very difficult to do research on commercial properties also in New Zealand because we have a lot less information about them. Yeah, this is only the good point. It's only residential properties. Okay. So the number here, the percentage, is the percentage of those houses that are owned by Hispanics, and you can see that the sort of this one now. There seems to be a concentration of Hispanics in the uninsured properties that were flooded because of climate change, right? Only in the uninsured, not in the insured, for reasons that are not entirely clear. Okay, but this one reason. So you can think, okay, but this is because Hispanics are relatively lower income, and we know that lower income, first of all, are less insured, and also they live in more hazardous locations, and to some extent that's true in Auckland as well. It's all true, but there's another group in Houston that is similarly low income, and that is the African Americans, and we don't see the same bias for African Americans, so the same sort of pattern. Why exactly we're not, to be honest, I'm not entirely sure. It probably has to do with the fact that a lot of the Hispanic community in Houston is new, sort of new in the region. So these are recent immigrants. Of course, there are Hispanics who were there way before the gringos came, but there's sort of two populations of Hispanics, right? There's the ones that came way back, and the ones that came recently. And we think it's about those groups that came recently and sort of went and settled in the places that no one else wanted to live in, basically. So that the most problematic areas. Okay? I'm saying communities because Houston is highly segregated. So that it's sort of, you can really see the pattern of by ethnicity. So that's why you can see this patterns. Okay. One more research project that I want to tell you about that looks at the same kind of approach, and that's together with Rebecca, who is from the Reserve Bank. And what we try to do is sort of, we've talked about out around New Zealand, we've talked about Hurricane Harvey, let's go global. Okay? So what we do is we look at all the attribution studies that people have done for specific events globally. So in the same way that for Hurricane Harvey, the scientists said 38% of the rain is because of climate change, people have done that for other events in other places. So for example, you remember there was a heat wave. I remember because that's my job. But there was a heat wave in the west coast of North America about 2 years ago. Oregon, California, British Columbia, Washington State, that region. It was a very, very dramatic heat wave. So there was attribution research on this, and they basically concluded that event would have been impossible without climate change. So fully 100% of the likelihood of that event is because of climate change. Okay? That event was very unusual. So in some places in Oregon, for example, they measured temperatures 5 degrees Celsius higher than ever measured in that location. Okay? So a huge jump in the measured temperature. Okay? And there's similarly other research on other events in tropical cyclone Ida in Mozambique and the floods in Germany that you might remember it was last year floods that killed almost 200 people in Germany. Various other events, and there is a bunch of attribution studies on it. So we collect all those attribution studies, which basically 250 papers on 179 extreme weather events globally. Okay, and then we match those with economic costs. So if you look at the conclusions from these attribution studies, right? So take heat waves, for example. That's on the left there. On average, 77%. The likelihood of a heat wave increased by 77%. Okay, globally in the last 20 years. Okay, the likelihood of floods increased by only 20% globally. Okay, that's why I said, my sort of ballpark guess for occurrence would be 20%. Okay, the average globally for floods is 20%. The average for heat waves is 77%. Heat waves are becoming much more because of climate change. With floods, it's a bit more complicated because it's not just the fact that there is more moisture in the atmosphere. For a flood, you need a certain pattern of concentrated rain in a specific period of time, and in some places, actually, they are drying up rather than getting more wet. We know that the patterns of rain is changing also in New Zealand, right? We are probably going to get more flooding in some locations, but less flooding in other locations, and so on. So what you can see there is, if I may, is for heat waves, it's 77% is the average, but some events are meaning 100%. That's that event in North America that I mentioned. And some events are only becoming more likely by maybe 40% of them. Okay, so there is a range, but the average is 77%. Okay? Now you wouldn't be surprised to know that cold waves are becoming less likely. Okay, globally. Okay. Not terribly surprising since we're experiencing global warming. Right? So you didn't need me to tell you that, but cold events are becoming less likely. So we are experiencing fewer costs associated with cold events, but more costs associated with floods and heat waves and so on. Regrettably, these costs are not very large. And if you look globally at what we are experiencing and have always experienced, heat waves and floods and droughts and so forth are much, much more destructive. And cold events have always been that. Okay. Then what we do is we match each one of those events, or those types of events, with the costs. So we use the global data sets for costs of disasters, and we match those two things, and we multiply. So if we know, for example, the cost of heat waves, we don't. Heat waves have one big cost, and that is higher mortality. Okay, we typically don't measure that. Okay, so we have very few instances in which we know what is the cost of heat waves. So heat waves are sort of not in our calculation because we don't know the costs. Okay, so if you look at the most popular global data set on disasters, that's a data set collected by University of Belgium, Catholic University of Louvain in Belgium. They have in their database of the cost of all disasters globally, there are no heat waves in Africa. Why? Because we never measure the cost of those heat waves. They also kill people in Africa, not only England. We do have how many people died in England. Remember it was last year when the first time we measured 40 degrees in the UK. We know how many people died. We just look at excess mortality around the time of the heat wave. Probably by now, after 3 years of COVID, you might be familiar with the term excess mortality. Yeah. So we know in England, but we have no in sub-Saharan, all of Africa. Just doesn't. It's not measured. because they don't have mortality. Okay, but what we do is whatever we can, we match with existing economic data, and then we calculate, okay, from extreme weather events, what is the cost of climate change? So the climate change part of these extreme weather events. And these bars are as percent of global GDP. Okay? So some years are much worse than others because we had some big events. But on sort of average, it's about half a percentage point of a bit less than half a percentage point of global GDP. Okay? But it fluctuates over time. It's roughly about 40% of the overall cost of disasters are because of climate change, or disasters associated with extreme weather. We have earthquakes. As a Wellingtonian, I'm deeply aware of that. But we're only talking about extreme weather. Okay? Now, is that a lot? Okay. You can actually put the dollar figure if you want. The dollar figure is $143 billion annually on average. Okay. So in the last 20 years, the cost of climate change in terms of extreme weather events was $143 billion. The next question is this a lot? Okay, it's more than we have. Actually, more than New Zealand has, but that's not saying much. We're a very big country. But if you look at, for example, you know, a good comparison would be how much are we willing to pay for adaptation and mitigation through the global climate negotiations, through the UNFCCC. You know, every year there is this COP, this meeting in November, and they discuss how much they're going to pay. And if, back in the Paris Agreement, when the Paris Agreement was signed in 2015, the world basically has agreed to pay $100 billion per year for mitigation and adaptation together. So both to cover the cost of reducing greenhouse gases and to pay for whatever adaptation needs to be done. In practice, only about 10% went to adaptation. So in principle, the promise was $10 billion a year. In practice, even that number wasn't really provided. Right? So I think we never reached 20 billion actually of the 100 billion costs per year. Right? So way underperformed there. But what I'm arguing here is just for that adaptation part, the costs we're already bearing is 143 billion. It's not the 10 billion that we've promised to pay for it. It's much bigger than that. Okay. So the cost of climate change, as we are measuring it, is actually way more than what we seem to be suggesting when you look at the negotiations. This what we call the UNFCCC, the United Nations Framework for Climate Change, something. I'm missing a C here, but I'm not sure what it is.
Crisis?
Whatever. Okay. Okay. So that's there is another. I don't have a slide on it, but the most common way to assess the cost of climate change is to run these what they call integrated assessment models. Familiar with the term, anyone? Okay, these are integrated. So these are models of the climate with a model of the economy, and they're integrated together, and you sort of crunch the models up, and you calculate the cost. And what we do in this paper is we show that our number is way bigger than what those integrated assessment models seem to be suggesting is the cost of climate change. Okay. Why? We argue because those integrated assessment models are, if I repeat the first slide I put here, they're looking at the average change in the temperature. That's the metric that they're using, and we think that they're using the wrong metric. What they need to be thinking about is extreme weather events and the change in the frequency and intensity, or intensity, whatever you want to call it, of extreme weather events. Okay. There's other things you can do with the same kind of approach. For example, I can calculate of that $143 million, how much each of you is responsible. Okay. Given your age, given your, how much commuting you do or how much flying you do, on average. So we know that on average how many kilometers of air traffic people do. Some do more than others, of course, but we know the averages. So we can calculate how much would my example, a 50-year-old, 53-year-old person male who lives in New Zealand, how much I've produced on average carbon dioxide over my lifetime, okay? And that will give me a dollar figure out of that $143 billion, how much is my fault? And equally I can do, for each one of you. Actually for every person. Okay. So you can sort of switch that and actually look at sort of the personal liability of each person. We're actually working on a project. I'm working on a project right now to try to do that. This is joined with some people from the UK. And I think the other interesting thing is that you can use this kind of attribution approach to start to convince people, if they need convincing, that climate change is real and is affecting them. So we are trying to design a project that looks at Hurricane Harvey, because we know exactly each property in Houston, which one of them were flooded because of climate change. So we are sort of trying to develop a project that actually we tell the people in those addresses, you experienced a flood, that flood was because of climate change. And then we can investigate whether they changed their views about climate change. So climate change denialism is not that common thankfully, in New Zealand. It's much more common in Texas. So potentially, can we shift people? Because when you talk about climate change and the cost of climate change, people don't understand that this is actually touching them. Right? But when you tell someone, okay, your house was flooded because of climate change, and if there was no climate change, your house wouldn't have flooded, then potentially that's a persuasion. We are trying to see if that is indeed the case. I guess it is, but I don't know. Okay. I think I'm happy to stop now and sort of explore questions.
Figures running over.